Let's take a look at Family Fun Binomial Probability. This is Lesson 4 from Unit 7. When will you teach this lesson? So let's take a look at the big picture to find out. First thing I would like to note is that this lesson is taught in both Math 7 and Math 7 Accelerated. Both, however, are in Unit 7 and both are the fourth lesson in that unit. So if you want to know what standards it addresses, helpful teacher tips and presentation strategies, then we can take a look at the scope and sequence to find out. Here you can see that in Math 7, this addresses Standard 14 and Standard 16. Whereas in Math 7 Accelerated, this is Standard 30 and 32. So our helpful teacher tips. The focus of this lesson is determining the theoretical probability of an event using a tree diagram to determine the probability of boy-girl combinations in a family. The presentation strategy is here and it's laid out. The students start off by doing the table at the beginning of class when they enter. Then numbers 1 through 3 are chunked, and then 4 through 6. And then later on 7 and 8, 9 and 10, and then 11 through 14. So first of all, here's the lesson. It's a 2-page lesson. But for this video, however, what I'm going to do is I'm going to try to avoid chaos by talking about this little chart here. And then also we're going to dig a little deeper into Pascal's triangle. So the big thing that I would like for you to know is to be sure that everyone has the same information in the table before moving on to problems 1 through 6. If any student is missing any of these options, the order doesn't matter as far as this one's listed first or second or third. But if they're missing any of these options, then when they go on to work on problems 1 through 6, their answers will not be correct because they did not start with the correct information. The next thing I would like to look at is Pascal's triangle. Now, I'll have to be honest. The first time I looked at this, it was very intimidating. I had never worked with it before. And so that's why I chose to take a few more minutes to talk about what this is and how you can use it. What I want you to know is that the single one at the top is considered to be row 0. So when it tells you to look for row 4, you will not start counting here. Instead, you'll start counting here, 1, 2, 3, and then row 4. So this is row 4 in Pascal's triangle. So write the total number of possible outcomes for each column on the last row of your boy-girl chart. And then what do you notice about those totals and the number in row 4 of Pascal's triangles? So if you take a look here, these are our numbers 1, 4, 6, 4, and 1. And if we take a look back at the table, you'll see that those same numbers appear as totals for each column. So let's take a look at one more example. This is not an example from the lesson, but I just wanted to go over it just to make sure that you had a clear understanding of binomial probability and using Pascal's triangle. So the question I'm going to pose is, what is the probability of having 4 boys in a family of 6 children? So you can see here that I have Pascal's triangle already. And because we have a total of 6 children, I want to find that 6th row, which is highlighted here. Now, the next thing you want to do is you want to create sort of a chart where you can fill this in. And we'll want to start with the maximum number of boys that there could be in a family of 6 with 6 children, which is 6 boys, and then work our way down to the minimum, which would be 0 boys. So we need a column for each one of these. And when we take these numbers from Pascal's triangle and fill them in, then you can see that there's one possibility of 6 boys. There are 6 possibilities of having 5 boys and a girl. 15 possibilities of having 4 boys and 2 girls, and so forth and so on. Now, when we're talking about probability, aside from the number of options that you have for that number, the other thing you're going to have to know is the total. So what we're going to do is we're just going to add straight across. I came up with a total of 64. And so we can use that 64 along with, here's our number of options, 15 different combinations with 4 boys in it. So the probability of having 4 boys, if there are 6 children in the family, would be 15 out of 64.